So I'm going to talk about recursion. Now, one of the common recursion problems that the book offers, and I've seen in many places, is the idea of solving a maze. So the way this works is you have a two-dimensional array. It could be an array of characters or integers, but typically they use ones and zeros, where one is the valid path and zeros would be like the wall. And we'll use recursion to iterate over this array. So I went ahead and just made a small program. The only thing I have is the main method, which has the array that we're going to solve. And I have a method to print, which simply just prints out the array. Now, the way it works with recursion, what we have to think about is we need to find our starting point. Now, the examples in the book always have you starting off at 0, 0 and ending at the end of the array, like the length row, length column. So you would end here. So you would have to find your way by figuring out which path has a 1, and then you take that path. And if you hit a wall where there's nowhere else to go, then you have to go back to where you started, or not necessarily where you started, but where you made the decision to take that route. So I do have this kind of pre-drawn up on my whiteboard. So kind of just want to talk about this a little bit. So what we're going to do as far as programming goes, what we want is we're going to start here, and we're going to end up we're going to start here. We want to end up right over here. Okay, so the way this is going to work programmatically is we're going to set up a method that is we're going to pass in the location of our starting point. And that method needs to determine, okay, do I need to go up? Do I need to go west? Do I need to go east or south? Right? Like so, up, left, right, down. Either way you want to look at that. In this case, if we were to check up first, you would see that we go outside the bounds of the array. So then we'd say, okay, we can't go that way. If we were to go off to the left, we also go outside the bounds of the array. If we decided to check going down, we would hit a 0 and say, okay, there's no path there. But if we were actually to check if we can go right, then we see that there's a 1 right there, and we'll go ahead and move down into this path. We'll continue this, right? We'll just hop to the next one. Or we hopped here, we'll check the same thing, check if you go north, if you go to the left, we can go down or to the right, and we'll determine like which way that we want to take. Okay, in this case, if I were to go to the left, I would go back to where I came from. Okay, so that's probably, a spot that I don't want to check because I just came from that area. So I don't want to check like the direction that I came back from. If I go up, I go outside of the bounds. And if I go to the right, there's a 0, go south, there's a path. So we're going to keep taking this path, right, making this decision. And as we go along, so far we haven't really had too many decisions where there's multiple ones. Okay, so this spot's kind of interesting. I can either go this way, the left, or I can go south. Okay, so if your algorithm chooses to go south first, then it's going to hop over here. It's going to keep going, go here. It comes to another point to where it needs to make a decision. Okay, if it chooses to go to the right, it's going to end up at a dead end right here. So the way the recursion is going to work is we're going to the recursion is going to find a spot, then call itself again. Right? If it's true, it's going to keep going deeper and deeper down the path. Right here is going to come back false. So it's going to say, you know what, it came back false. So you're going to hop back over this spot, and then you're going to find the next path. Okay. So we're going to keep checking. Another decision right here. If we decide to go this way, right, there's two methods that we're going to have to invoke in order to go here. But once we get to the spot, we found we're at a dead end. So we're going to have to hop back to where we made our decision here and go this way. Okay. And then we're going to find out that there's another dead end right here. So we're also going to have to return false here and come back to this point and say, you know what? There's nowhere else to check. I need to go all the way back to this point right here. Okay. Now we're back here saying I took that path recursively, calling myself over and over and over again, and now I'm back to where I made that decision to go down that other way, and this is where it's going to make the decision to go take this route. Okay. And then there's no other decisions to make. I mean, every time you go to a spot, you're always going to check if you go up, down, left, or right. But there's only really one path that has ones, and it's going to lead you to the end of the maze. So this is a typical problem you'll see like in a lot of different programming languages. The book has it to where 0, 0 is the start, and the end is the length of the column and the row. So this would be the stopping point. Now I have seen some mazes that actually it doesn't matter where you start up here. You're only going to have one entry point here, and you're going to only have like one stopping point right here. Okay, so that is it. So let's go ahead and talk about typing up the actual code for this, which is going to be, a little complicated when you think about it, but I'm going to do my best to kind of talk about the different steps that are necessary to solve this problem. So I'm going to hop back over to my code. I do have the maze already created. I went ahead and took it upon myself to do that. And I just made a method to go ahead and print out the maze so I can have it looking like this. Now, I don't know how your guys' eyes work, but when I look at that maze is actually like pretty difficult to understand what's actually going on. The ones and zeros, I don't understand why it's always ones and zeros normally when programming problems. But I actually prefer to use spaces so I can actually see like the holes in the maze. Or you can use like smaller characters that like maybe like the period. It might, like using a period might actually make it appear like there's a hole. So what I'm going to do is I'm just going to find and replace this one here. So what I'm going to do is to Control R, and I'm going to find one, and I'm going to replace it with a space. I'm going to do replace all. I'm going to go ahead and run this again so you can see what it looks like when it's printed out. So to me, this is a little easier to visualize, where you can see the holes in the maze, like different paths that you can take. That's just the way I prefer to look at it. Another thing that we could have done is maybe use like a smaller character, not necessarily a space, but maybe like a period. Replace all, and I'll go to run. And you can see that there are periods now, so that like might be a little easier to see than maybe the space, because when your eyes look at the space instead for the character, it's also seeing like the space around the maze. So like the dots are the paths that you can take. Okay, either way you do this, it's fine. I know like if it is an integer, right, if it's a two-dimensional array of integers, then you won't be able to use like a dot or space. You would have to use actual numbers. Okay, so now let's think about this. We have our starting point. Now we need to make a method that is going to check to see if we're in a valid spot. Okay, before I actually make the method that we're going to call recursively, I want to make a method that is going to check to see we're in a valid location. So if a location is valid, then it is in bounds, and we'll say that it's a dot. Okay, so we're going to say like public static boolean is valid spot, and you're going to give me a row and a column. So then what I'm going to do is I'm going to make sure that if row is greater than or equal to 0 and row is less than or equal to, I would say less than 10, and column is less than or equal to 0. I did the wrong end over here. And column is less than or equal to 0, and column, oops, I'm sorry, it should be greater than, is greater than or equal to 0, and column is less than 10. All right, so if that is true, then we are going to continue to check to see if it's a valid spot. And the other check that we need to do is check to see if the, let me see, I'm going to need the array also. So say char, taking the maze. We're going to see if the maze at R and C is equal to a dot. Then we know that it is valid. Okay, we return true if it is, and return false if it's not. All right, so the next thing we need to do is write the recursive method that is going to do this checking. Okay, so the way this is going to work is I'm just going to say like public static boolean, and then I'll say, let's just call it traverse. I seen traverse, I seen move, I seen check. I'll just go with check spot. All right, and this is also going to take in the array, the row, the column. All right, and what I'm going to do is, the first thing I want to do is verify that it's a valid spot. All right, so what I'm going to do here is I'm going to call the method that I just made above, called isValidSpot. I'll pass in maze, I'll pass in row and the column. If it's not, then I'm going to return false. All right, and then what I want to do is in here, I want to check to see if I reach the end. So if you reach the actual end of the maze, so that you can say, okay, well, if row, so you know your valid spot. So if row is equal to 9 and column is equal to 9, then we could just return true, meaning we solved the maze. Actually, I should probably change this method now. So instead of saying check spot, we'll say, we'll just call it traverse. That's what I've seen everybody use. Traverse, so we return true, meaning we made it. So we made it to the end. So this is the path that we want to take. So we're going to return true, and the only reason we know this is because we made it to the last column, which is this very last one. Put on my whiteboard right here. Right, we made it to 999. Now that we know that we have a valid spot, but we have more to check, we're going to continue checking. So we're going to check to see. It depends on what order you want to do. You want to check right first. I don't think it matters. I've never really ran into a problem. But we'll just say we're going to check up. We're going to check down. Check left and right. All right, so if we're going to check up, then what we're going to do is say, okay, well, we're going to need to make a return value here. We're going to say Boolean return value is equal to traverse. We'll pass in our maze, R, and C. Now, if we're going to check up, then that means we're going to subtract 1 from this row here. Okay, we're going to continue to do this if it's not true. So if the return value is not true, that means you went down that path and you were not able to solve the maze. Then you're just going to say, okay, well, if return value was not able to solve by checking up, then we're going to check down, and down would just be a +1. And we're going to do this for left. We're going to do this for right. Okay, so if we move to the left, we're going to subtract 1 here. If we move to the right, we're going to add 1 to our column. And once you're done checking all the possible routes for this spot, then you're going to return the return value. But you might want to check to see what do you want to do. I think if we return true, we want to like maybe say something like we took this path, or just do something to indicate what direction we took. Okay, but we'll come back to this. Now, one of the things we also need to do before we actually run this is we need to mark which path we took. So the way we're going to do this is we're actually going to have to change the array of the maze. So as we marked a valid spot inside of our traverse array, what we're going to do is, before we begin anything, is we're going to say, well, every time I have a valid spot I'm going to try, I'm going to go ahead and mark it with some character that is not the dot. We'll just use an asterisk to say, okay, well, we tried that spot right there. So we know, we look at it again, like it's almost acting like a wall because we tried it. Okay, so now what we're going to do is we're going to hop over to our main method that prints the maze. I'm going to go ahead and copy this. We're going to just say, okay, well, if we traverse our array, we're going to start at 0, 0. If that returns true, then what we're going to do is just say something like system.out.println solve maze. Okay, anything else would be like we couldn't solve the maze or something like that. So system out could not solve maze. All right, let me go ahead and just tone this down a little bit. Could not solve maze. All right, so I'm going to go ahead and just run this really quick. And you can see that we're able to solve our maze. Now, we don't have any like indication of what path that we took, but because I'm actually modifying my maze as a mark spots that I've taken, I'm gonna go ahead and print the maze again, and it should show the X's of the asterisks of what paths that we took. Okay, so as we did a path, right, like we selected a path, we marked it, okay, we moved there, we moved here, we moved here, and it looks like we stopped there, we went back around, and we went through here, we went through here, and then like we made it right there. Now, never attempted, so in this spot right here, it never attempted to actually go right, okay? It just went down before it went right. So like if I were to actually move, if I were to come down to my method traverse, for this particular array, if I were to move this before checking down, then you'll be able to see that it actually goes the other way at that location and checks all those spots. All right, so this is pretty interesting now. So you can see that we went this way, we came here, it checked the right, it did all of this, right? It ended up at a dead end. So then it came back over here, and it came over here. Instead of going down here, it checks right first. So then it goes down this way, and it ends right over here. Like you can also like print out the path, like which path that you took for success. And the location that you do that is when you found a true spot. So we'll come up right here and right here, and we'll just do something like, okay, well, if the return value is true, then we can like print out our spot. We can just say like system.out.println what, like row and column. Go ahead and run that. Now this is going to be backwards, unfortunately, so it's going to show you the last spot that it took, or the first spot that it, like, so here's what you printed out. It's just basically telling you like what path it took. So it went from 0, 0, 0, 1, 0, 2, 1, 2, 1, or 2, 2, 3, 2. Right, so let's see what our maze looks like. It's basically saying it went here, it went down here. Then it's gonna go all the way to 0. Let's see. It went to like 0 here, and then went 5, 1, 5, 2. Like on the fifth line, right? So it's already going this way, and like it's showing us what path it took. Now it is backwards. I understand that, but the way you can solve that is by like putting it into an array list, or some type of list to where you're pushing them in, and then when it's time to read it, you pop them back off so that you can get the exact spot. Another thing that you can do, just to kind of show which path that you took, you can also modify your maze with a different character. Let's just say at R and C, we'll go ahead and just, every path that was successful that we took for this path, we're just gonna make it a blank. Okay, let me close this, find and replace, and go ahead and run this. All right, and the asterisks are directions that you took. All right, so we're marking them like, hey, we went this way and it didn't work out for us. But the blank spots are the actual successful path to our location 0, 0. All right, so that's the way you use recursion. I know this maze one is a little confusing, but essentially you're basically you're checking, you have like a method or some type of path that you're checking, like either you're going up, you're checking right, down, like it doesn't matter which order you get those in. But what matters is if you return true or false. So for this spot, we're going to say, okay, well, let's check all the way up. Okay, that came back as false. Okay, let's check all the way right. Okay, and as you check the next spot, it's going to check those 4 locations. And the next one of that is going to check those 4 spots. Like it's going to determine which way it can move. If it doesn't reach the end, everything is going to return false, and it's going to come back to the location of that spot that you've like had to make the decisions of it going up, down, left, or right. Like to make this maze unsolvable, because we have code here to, like once we reach 9, we have code here to check 9. If we were just to make that a 0, then this maze becomes unsolvable. So now when we run this program, right, everything's an asterisk. It's telling us we could not solve maze. All right, so that is how recursion works when solving the maze.